We're here in Bristol to see CEL, a UK company about to launch a new award-winning 3D printer, Robox. Today we'll be meeting Gordon Attenborough, head of the design and production sector at the IET. He'll talk about the significance of 3D printing. And then we'll be meeting Chris Ellsworthy, the co-founder and design engineer of Robox, who'll demonstrate the product and show us what sets it apart. So Gordon, it's great to be here at CEL. Explain to me why we're hearing so much about 3D printing.
Well, it's not a new technology. It's been used in industry for several decades, but it's really started to capture the imagination more recently because it's moved out of the industry sector and into the home. It's a technology people can relate to. We're talking about the sci-fi generation, the replicator from Star Trek. This really is the device that can mean people making stuff in their own homes.
Are there lots of differences between an industrial machine and a home market machine?
Yeah, absolutely. I mean, the uses for them in industry typically are around rapid prototyping, although there's now a move towards actually using them as part of the manufacturing process. But it's the cost of those machines. They can run into the hundreds of thousands of dollars for each individual unit. And the materials that they're using are also extremely expensive, so really not accessible to the home market. In the domestic market, we've now seen a rise of typically polymer extrusion machines. These are under $1,000. People can plug them in their own homes. They don't need a huge amount of technical expertise to use them. And this is opening a whole raft of opportunities. People can design something and then produce it in their own home the same day, and that's what's exciting people.
What's so unique about Robox?
Well, I have to say I am particularly excited about this innovation. Not only is it a British company, but really it's the accessibility of this particular product that takes it that next step further. Yes, you don't need a lot of technical expertise to have the current machines, but they need calibration. You need to be very careful where you put them in the house, how you set them up, make sure they're level. There's a lot of work. It's not a plug and play machine. Robox looks set to change that.
Chris, it's brilliant to be here. Can you just explain a bit about CEL?
Okay, well, I studied as an industrial design student at university and worked through a few companies. And CEL was an opportunity for me to design, develop and sell my own products. We started to buy in 3D printers to improve or reduce our overheads on manufacturing the prototypes, but very quickly we started to modify the 3D printers we had to improve them and mean that my engineers weren't spending so much time getting the parts they wanted from the printer rather than just getting on and designing. So at that point we almost developed a new product already for ourselves, and we realised that this might want to go forward and sell to other people. Initially we used the funding from the capital and cash flow we had from our power tools side of the business, but we very quickly realised this is a much bigger project than ones we've been used to in the past. So we then looked to gain money from the people who would actually buy the product eventually, so almost pre-sales or investment from the public. So there's websites like Kickstarter who are peer-to-peer funding websites, and it's great for companies like mine because you can get people that want to be invested in new technology, they're right at the bleeding edge of technology, to invest in projects they're keen on, which means you can compete against the larger corporations obviously developing this sort of technologies as well. Our ultimate goal, I mean the end game for us really is that everybody's going to have a 3D printer. We really want this to be as populated in the world as 2D printers are now. The truth is right now probably the general public aren't quite ready for it, but what we're doing here is designing the project Robox to be ready for that upcoming market splurge where people start to accept this technology into their homes and build it into part of their life.
And what do you think people are going to do with this sort of thing? If they're using it at home, what are they actually going to be making?
So I can only give you examples of the way I use it at the moment. I mean, for me, my two children, I've got two boys, one's into a connecting system called Connects and the other one's into Lego. And normally those technologies are completely separate, but they actually build parts on our 3D printer which interconnect those abilities. So the real core about 3D printing is that it's so customizable. You can literally make anything you want. And normally when you tell an adult you can make anything you want, it doesn't really help them. But if you tell a child that you can make anything you want, their imagination just goes crazy. They get hold of the technology and they can really use it for what they want. I think through this recession we've seen that it's so important to bring manufacturing and design back into our own country. I mean, places like Germany at the moment who've kept a very strong manufacturing background have kept their economy very strong and booming. And I see 3D printing as a way of bringing the kind of makers and the engineering back to the public. I mean, if you've got the ability to produce things, anything you want, on your desktop at home, that can only be advantageous for you moving forward and being creative in the future. It is the pinnacle of design quality when you get something that works perfectly and seamlessly. I mean, everybody uses the kind of Apple iPhone sort of scenario where you pick it up and you just start using it. And it's exactly the same kind of scenario when you work for 3D printers. If you want to print a part and you want to, you don't want to spend 2 hours setting up the machine, fiddling with it, learning how to use it, and going through a huge development curve before you get what you want from the end result to be. So it's so important that you just press print and out to come. And that's exactly what we're trying to do with Robox. That huge learning curve that is how to use 3D printers, we're trying to build all that technology into the machine so you literally just press print and out come the results. Robox is be able to use on any kind of OS system, and in the future we hope to be able to improve that and go on to like mobile devices. And the good thing about 3D printing at the moment is that the technology is moving on really rapidly and new things are coming out all the time. And you've probably seen in the market there's loads of 3D printers popping up all over the place. And what we've done with Robox is we try to make it future-proof for all these kind of new technologies. So, for example, the head is really easy detachable. So maybe in a couple of years' time when there's a new sort of head that prints better, you can just detach the head, attach the new one and off it goes. And the whole system is based around this kind of modular system where if you need a new extruder, you can just take out the extruder and plop in a new one. So, and the real beauty of this comes when you think about what you can do with a 3-axis machine. So once you've got that kind of X, Y, Z movement in a machine, there's so many applications for that. So today it's the best 3D printer, but tomorrow it might be icing your cakes. The day after it's doing a pick and place circuit board. The day after that it's doing a milling. Once you've got that XY stage on someone's desk, then the possibilities are really endless for making and manufacturing.
Fantastic. So hopefully now you're going to be able to demonstrate some of these features.
Yeah, of course, yeah.
First place we need to start presumably is something in the software that we can actually look at to print.
So you see that very quickly we've got a visual representation of the printer. We're trying to make it as simple as possible to the point where you've got very easy controls. You've got the home axes left and right, and they all work as you'd expect them to, movement axes. You can even do things like switch the lights on and off from here and the fans on and off if you want to get more adventurous. So that very quickly takes us on to the next stage of software. So this is the kind of status page of what the printer's doing. So you can see that it's open and nothing's happening. It even shows you the filament. So if I just pull out the filament, you can see that that comes in and out.
Yeah, amazing.
Very quickly, and you'll see on the software that appears, and it's automatically taken from the reel all the information it needs to know about that material for printing. So one of the unique things about our Robox is that it automatically sets up itself. So if somehow the bed's slightly twisted or the components aren't quite as they were when it was sent out from the factory, the machine will automatically calibrate itself to the position where it is now, automatically level the bed and calibrate the firmware so that it prints perpendicular to the bed. So this is the 3D environment part of the software, and down here is very simple controls, and you just select what you want to put on. So in this case I'm putting a rook, a chess piece, and you can move that around on the bed, duplicate it and move it around so you can build up a whole chamber or build plate of the things that you want to create. For speed we'll just put one on for now because obviously the more you want to print the longer it takes. And then that's it. You can change the scale, size, position, the things you want to put on there, and then you go to the next layer, and it's very much this stage like a 2D printer. You just select the quality, and the moment we're in draft, normal or fine. One of the great things about Robox is the print resolution can go right down to 20 microns, which is a really high resolution. In fact, it's even higher than some of the more traditional prototyping techniques on the market at the moment. But in draft, you can obviously create things very quickly, so it's a very robust technology. And one of the best things about 3D printing is that you actually build these prototypes in the material that you want the final part to be in. So at the moment you can see that we've got a green ABS roll on there. It's automatically set up the machine for that material, and it's as simple as pressing print. So you just press print. What it does now is it takes that model, that STL file, slices it into layers, changes each layer into what we call a G-code file, and plots the path through each code, and the robot takes that information through the firmware and digests it onto the bed and makes the part in front of your eyes.
So Chris, here's a print head. Explain to me what's going on inside the print head.
So this is one of the key innovative features of Robox, and what we've got here is 2 nozzles, unlike other systems, which can attach to the same extruder. So the fine one, the 0.3mm nozzle, does the outside perimeter of the print, keeping the detail very high, and the 0.8mm nozzle fills in the inside very quickly, which means we can have about 300% increase in speed over our competitors. If we take an opened up case here, you can see a bit more of the gubbins inside which makes that system work. One of them being this needle valve closing system, which actually penetrates the hot block here and comes right down to the tip, which means you can close the flow of material very precisely right at the tip, and also obviously close one nozzle off when you're not using it and open up the other one. The motor which makes that operation happen also has another lobe on the cam which can articulate the head, so you can go from printing with one nozzle to the other nozzle and lift it up the one you're not using to get it out of the way of the print surface.
Brilliant. What other things are important inside the actual hardware?
So to feed the material to that, we have this, which is basically the extruder unit. So if I just stick the lid on there. So this is a very innovative part of the 3D printer as well, the Robox system. And if I just take the cover off here, you'll see that we've got a few innovative items. Well, first thing is we drive our filament from both sides, and we have a very high ratio. We've got a worm drive there for 10:1 reduction on the stepper motor, which means we can very precisely control the flow of material. We've also got here a feedback system, which is missing from most 3D printers, where we can actually monitor the flow of the filament into the machine, and that gives us the ability to fault find and also to have things like auto material load. It also enables things like pause, resume, auto eject, and things like that, which other printers suffer with.
So it sounds like it's finished printing. Can we have a look at the product?
Yeah, let's grab that draft print. There we go.
That's amazing. So what makes that a prototype as opposed to more of a finished article?
So this is set at draft quality, and that basically means the number of layers you're putting down and which nozzle it's using for each layer. So here we've got 300 micron levels, it's quite thick, but the printer itself will go right down to 20 micron layers, a much higher resolution print.
Well, it's an amazing product, Chris, and you know, I think we're going to see a lot more of this product out there in schools, colleges, universities, all over the place and in the home market. So thanks ever so much for having us down here at CEL, and good luck with the products in the future.